Hey guys, welcome back to Walker's Workshop. I got just a quick little short video for you here today. It might help out a bunch of yous, might not be so helpful for some others, but we're going to learn a couple things, throw a little technical information in there for you guys, and let's get to it. Alright guys, let's get started here. I want to talk about first what we're kind of working on. 3-point attachment for the subcompact I have. If you guys have been following along, you subscribers know what tractor it is. Just a simple drawbar attachment. As you guys know, the 3-point hitch can be used for a gazillion different items. We're going to make a nice little attachment here. Can use it for a whole bunch of different tasks, for hanging weight brackets. We're moving trailers around, we can bolt a hitch to it, for towing logs, whatever you guys could come up with to use it for. Just gonna be a quick video how to build it and why we use the 3-point hitch. Let's get to it. So the first thing we're going to need is to find our dimensions. So I went ahead and I took some measurements on the 3-point hitch of the tractor of a couple different implements that I have, and what I found is from this, the center of this pivot pin height wise directly up to the top link is right around 17.5 inches. So the way I'm going to lay this out here, I'm going to take this drawbar, set it flat on a table just like it would be as if I was facing the back of the tractor, if the tractor was like pointed straight down at the ground, right? So this is, I'm going to use this as my layout here. So I'm going to take this, use the edge of my table, it's kind of a straight edge here, and I'm going to tack it fast so that way it won't go anywhere. Turn the bottom on. Turn the welder on. A little quick tack here. Quick tap there. That'll hold it. Okay. So what we're going to be using for this is some 2-inch by 1/4 inch thick flat iron. We need to figure out our pieces, so let's take some measurements. Actually, before measurements, we need to find the center line. You could find the center line with your tape measure. Just so happens this drawbar has a hole right directly in the center of it, so we'll just use that for reference. Take our square it up here and draw our line. So this line, I hope you guys can see that well enough, that is our center line. So up here somewhere is going to be where the top link is going to be. So we need to find our dimensions, how to come up here. So at 17.5 is going to be the center of our pin at the top. We'll measure from the base of that. Okay, the thickness of this is 1 inch, so I'm going to take the base of this. Half of this thickness comes up here. I'm going to come up, put a mark right at 17 inches. All right. So this is where our top pin is going to come through, right here. So the width for the opening on the top is right around 2 inches. So I'm going to measure from the center line 1 inch to the right and 1 inch to the left. Okay, and this is where our sides will be. So now, there isn't any sort of real technical drawing. They're very vague, the ones that are out there. They're very generic. So I believe what I'm going to do, from the center of the pin, I want to come down and leave myself, we'll just say I want to leave myself a 3-inch opening. So I'm going to come down 1.5 inches from that center line. Okay, 1.5 inches, put a mark here. I'm going to extend my 2-inch lines down to this point, here and here. Use my smaller square to make these points here. Square up with my center line. Come on, fingers. One to the right, to the left, and one to the left. So, at these crosses right here, up and down, up and down, that's where our angle is going to come to a point. Right here, this is where our bend will be. So this will be, we'll figure up, we don't really even need to measure an angle. Doesn't really matter what it is. So I want to come in from the end of this. I want to come in, let's call it, handy dandy tape measure here. So we have 3 inches to the first hole on the end. I think we'll split that in half. We're going to go 1.5 inches. Okay, so we'll put a mark right here on our table. At 1.5 inches on this side, 1.5 inches on this side. Use our square. Mark our line from our 1.5 inch point here to our cross up here. Okay, that's going to be one of our uprights. We'll do the same thing. Screw it over here on this side, flip it. From one point to the other. Okay, so since I came down 1.5 inches, I need to go up 1.5 inches. Put a line here. Take our square, just so happens to be our square is 1 inch thickness. Mark it out like so. It'll be just like that. So here, our center line of this hole, this is going to be where our pin will be. So, pin. This technically this is irrelevant except where we're going to drill our holes at. So let's get some metal cut up. Basically we're just going to take this angle, length here, plus 3 inches at the top. See what we come up with. Looks like that is going to be 18 3/4. Double check this side, it should be exactly the same. Going to be, yep, 18 3/4. So we have 18 3/4 plus our 3-inch rise. It's going to be 21 3/4. So this height up here doesn't really matter. You can make it whatever you want. I just gave it 3 inches because I thought that seemed to be about a pretty good dimension there. I will cut a cross piece here. Now remember, I did say that this is going to be a 2-inch opening, so this will be an easy measurement. Just going to be a 2-inch piece to go across here. And your uprights. And that's it. Let's get some material cut. Okay, so we got our material cut. We got our 2-inch piece in there, our 21 and 3/4 inch pieces. I went ahead and set up my angle finder here. I think that works the best when you're doing this kind of stuff. It's easy. You can already have it drawn out there. You know exactly what you need. Went ahead and measured my marks. I actually moved it from 3 inches to about 2 3/4, just because I didn't really think I needed it. Kind of wanted the extra space. So we'll go ahead, we'll get this bent up, see how it fits. If you guys weren't here following along with us when we built this press brake, go back to my channel, Walker's Workshop, and check out the video where we build this press brake from basically nothing. And subscribe, follow along so you can learn some more stuff along the way. So we're going to slide our metal in here and make sure that our line here is even with the point of the bending jaw. We're going to put it in there. Make sure that it is nice and parallel or perpendicular with the jaw. So that looks pretty good. I think we'll start bending. So remember, we're not bending this in a complete 90, even though with this press brake we certainly could. We have our angle finder here to tell us what we need to know. Bend it a little bit, see what it looks like. Definitely going to need to go a little bit more. If you can see here, I started bending it a little bit. I still got a little ways to go. So now, since you already have it started bending, you've been putting that stress on the material, your line probably will go away, but you still have the line from the jaw the first time. So you just line it right back up to where it was and go from there. So let's see, give it a couple of more cranks, let's see where that takes. See, we actually went just a little bit too far. No big deal. We can you could straighten this out by either putting it in the press this way, flattening it out. You could do it a bunch of different ways. You just beat it with a hammer, whatever you see fit. So we got this one. Let's get our other one bent up. See if we can not go too far with this one. So I'm putting it in there, lining it up, making sure it is just right, nice and square. Start bending. So if there was a way that you could somehow get this in there, you could kind of eyeball it maybe. I don't really know how that would work. Okay. So now that we have our pieces cut, we'll or bent, I mean, we'll bring them over here to the table and see what they look like. Alright, sorry about that, guys. A little technical difficulty with the camera dying and stuff, but no big deal. The only thing I did off camera, I'll show you guys. I bolted, well, I clamped these two pieces together, drilled my hole through here. That's pretty basic, straightforward stuff. And I threw 2 1-inch spacers in here because I want this 2 inches apart. Put a bolt through there to hold everything together. And basically that's all I did. So you didn't miss anything much. So I've got my drawbar here laying down on a table. We're going to set this up right on my marks that I made where I want it. Make sure everything looks good. Double check our measurement here. Okay, I wanted, if you remember, 17.5 inches. If you can see, let me move the camera here so you guys can see a little better. I wanted 17.5 inches from the top bolt to the center, and I am right there. So that looks good. I'm gonna get this thing tack welded up and get her finished up. So you'll see what I did here. I took my welder and I pushed out some wire. I run 30 thousandths wire, and I just put 2 little spots of wire right there. Well, the one broke off. I got one here, the other one broke off. And the reason I did that was when you're welding something like this where it's got to be pretty sturdy, you want to get the most out of your welds, the most penetration, the most quality out of your welds. Ideally, you want to be 100% weld between this piece and this piece, because, so let's just say half of the thickness of this is touching the surface. Well, that thickness in the half, it's not doing anything. It's just sitting on top of there. But if you have 100% weld between this and this, and there's no gap, there's nothing in there that's wasted at all, right? Everything is pure structure that you've put in there with the weld. So let me get the torch fired up so we can clean this stuff up, prep it for weld. If you're wondering why I'm using the torch, go back to one of our later videos that we made. It's all explained in there. Walker's Workshop channel, obviously. And don't forget to subscribe. You can see all of our tips and tricks of the trade. So let's get her fired up. You see that stuff popping and cackling off of there? That's the mill scale. That's the stuff that you don't want. You'll see in, I don't remember which video that was exactly, where we went over that. What were we building in that episode? I don't remember exactly what episode it was. But go back through and watch through the videos, and oh, it was the video where we made the press brake for building this thing. You'll see just why I use the torch instead of a grinder. Some people use, you know, an angle grinder. Some people use, you know, a little whiz wheel die grinder. There's lots of ways you can do it. There's a couple of certain reasons why I prefer to use the torque over other methods. But check out the other video and you'll see for yourself. Okay. So I've got that prepped. Got a good connection with the table. Turn our gas on. Make sure this guy's centered. Make sure our top bolt is tight up here so it stays square. Okay, so see, I'll stick a little bit of wire out like this, put it in between my two pieces. I don't have a good ground. There we go. There, see, now I got that little piece of weld wire on there. It'll stay fast. So now there will be that thick of a gap in between there. Yeah, so you guys can see that. Let me move the camera closer. You guys can get a better look just at what we're doing. Alright, so I moved you in a little closer. So I took a little welding wire, put it out of the tip just like that, put it in between the two pieces of metal that I want to weld together, and I just tapped the trigger real quick, and it leaves that 30 thousandths of a gap in between this piece of metal and this piece of metal. So now you'll be able to get 100% between this piece and this piece. There's nothing but air. You'll be able to fill that 100% with weld. That's going to give you the very best possible connection between the two pieces. So we'll make sure everything is straight and square and even and happy. I'm gonna scooch him over a little bit this way. Take another measurement. I got about 1.25 inches from that side. About 1.25 inches from that side. That looks good. So I'm gonna go ahead and we'll tack weld this up. That one's even. And that one's pretty even right there. Okay, so we've got this side and that side tacked up. I got my little cross brace here for between the middle, and you'll see, you can see these my little spots of welding wire in there. It's exactly what I want. So when I put this up in there, I don't know if you'll be able to see 30 thousandths of a gap in the camera. There, you can see it right there. It's just the thickness of the welding wire. See, that's going to be 100% weld between that top piece. Between the cross piece, this one and this one, that'll be 100% welded in between there. So tack weld in. Losing my ground. There we go. It was the tack welded good enough. Make make sure he's nice and flush. That looks good there. We'll remove our bolt now. Make sure that looks good there. Get my spacers back in there. There we go. Okay, we're going to leave him in there just to ensure everything stays exactly where it needs to be. So let's get her welded up, and we'll see what it looks like when it's done. Alright guys, so I gotta show you something firsthand here. I guess I didn't get a chance to show you for sure on the press brake that we built, but as you just saw there in the video, you know, I preheated when I did these welds, but I did not do it when I did these down here. Well, on this side I did. So take a look at these welds. They look much better. They're really nice, burnt in real deep. I preheated that, burned out all the crap and junk that was in there. This side, as you saw, I did not. And goes to show that these welds do not look near as nice. So I'll probably put a couple of cover passes over them. I'll heat that up a little bit, put some cover passes on it. But that's firsthand how the difference between doing a little preheat, burning out all the gunk, what do I want to say here, the debris, the garbage that's in the metal, the oil, all the contaminants that are in the metal, in that mill scale. You got to get that stuff out of there if you want a good, I mean, if you had a great big 480 welder, 220 welder or something, you could burn it like super hot and it would burn that stuff out before. But if you're just a DIYer, which is what this channel is all about, and you only have a 110 welder like me, this can turn your 110 welder capabilities into a much larger machine. Real simple hack. So this is it basically. The whole point of doing this is you could put a ball hitch on here now to move a trailer. You could you can buy them Tractor Supply or Menards or whatever you have, the bolt-on receiver hitches, so you could exchange whatever hitch you wanted in and out of it. Put a clevis on here on your 3-point. You don't have to worry about this bar flipping around. You could weld weight brackets on here, or maybe some tool holders, a toolbox, whatever you want. Now you have this nice little structure here that we built for on your 3-point hitch for your tractor. We'll take a minute, go over, do some technical talk about why the 3-point hitch, as far as heavier lifting capabilities, more stability. We're just going to talk a little bit technical of why this is better if you can use a 3-point hitch to lift or move things around than it would be to use the front end loader. So follow along, we're going to see what it's like. Alright guys, so now I want to talk a little bit about why would you use the 3-point hitch to lift stuff or move stuff around. If you have a trailer, you move around your yard with it, or if you're pulling logs out of the woods, you know, to cut for firewood or whatever you're going to do with your tractor, why would you use the 3-point hitch over the front end loader? So a couple of reasons personally that I feel why I prefer using a 3-point hitch. One is for visibility. This kind of a rough drawing here, just general. This is your tractor, okay? As the operator, you're sitting back here over the rear tire. So your visibility to see the 3-point hitch is much greater than it is to see over the hood of your tractor. A lot of times your loader bucket is going to be on the ground down below where you can see it. I've seen a lot of people really like the hitch that you could mount on the bucket, you know, like bolts on the top edge of the bucket, and it's got a little receiver there you can slide a hitch into. I'm not 100% sure how well you can see that. Maybe you could see it really well. I don't know that. I'm not 100% sure. But it definitely is farther away. That's one reason. The other reason is it's not quite as hard on the equipment. Not that either way, if you're within your lift capacity, either way, it's not really going to be, you know, excruciating or damage your equipment in any way. But stability wise, the 3-point hitch is much more stable. And I'll go over, these are just general numbers. It's not anything that I know, like the weights or anything in particular. These are just general numbers I'm throwing out here, really generic stuff, so you get the idea of what's going on. So the 3-point hitch arms, as everybody knows, are much shorter, obviously, than the front end loader. So I'm just going to represent them by, say, 25 inches, because that's about what they are, about 2 foot behind the tractor. The front end loader generally is much farther out in front of the front axle. So I estimated about 50 inches. My tractor in particular, I have a Coyote CS2510, is actually 54 inches from the center line of the axle to the cutting edge of the bucket. So the cutting edge is obviously the farthest point. If you have one of those hitch mounted receivers bolted on top of your bucket, you're going to cut that back a little bit. So I just estimated right around 50 inches. So, and I went with 25. For one, it's simple because it's half of 50, but 24 inches is actually where the specifications on the brochure for the tractor is measured at. I don't remember exactly what the lift capacity was, like 1,200 pounds or something at 24 inches. Okay, so the reason I say, and it's just a simple lever, right? It's just a giant teeter-totter is all we're talking about. So if we have a 50-inch wheelbase, like I say, I'm doing this because it's simple, it's easy to visualize, right? If you have a 50-inch wheelbase, which I don't believe is too far off for real for most subcompact tractors, and just say in general, the tractor is 50-50 front to rear, which we all know they're probably not, but we're just going to go with that because it's simple, right? So 750 pounds front and rear axle makes the tractor total of 1,500 pounds. So let's say you're towing a log out of the woods, or you have a trailer, and the tongue weight of that trailer or the log is going to be 500 pounds, okay? At 25 inches, 500 pounds is pulling down here. So in order for this to be perfectly balanced, we would come forwards, right? That same 25 inches, which would be pushing now upwards, taking the weight off of the tractor at 500 pounds, right? So you got 500 pushing down on the back. You'd have 500 lifting up on the front at equal lengths. So let's just for curiosity's sake now, let's go the 50 inches. Let's go to the wheelbase. Let's go to the front axle and see what's going on over there. So we're going to go that extra 25 inches more. So we're at the front axle here. Now, this is going to be half. Now, out here, you're only going to be lifting up at 250 pounds. So now, off of the front axle is going to be this 250 pounds because as a teeter-totter, right, you're lifting the front axle. If you've ever been to a tractor pull, you see those guys popping wheelies, you know, as the chain is pulling down, the sled's pulling down on the back, the front tires are popping off the ground. So now on your steer axle, you have 500 pounds. Well, the weight doesn't just magically go somewhere? Where did this 250 pounds went up, 500 went down, but really where did it go? It went right here on this drive axle. That extra weight went right here on this drive axle. So which axle do you think is more beefy, the front or the rear? Well, obviously the rear has the whole differential housing, the transmission is all incorporated into one. This axle now is carrying all the weight of this 500 pounds you put down here, 250 pounds off of here, off of the front is being transferred to this rear axle. So now let's do it the other way. Let's go with the front end loader doing the same job. Okay, same thing is applied here. We're going to unhook our 500 pound log off of the back, and we're going to put our 500 pound log right here on the front. 500 pounds at 50 inches. Okay, so now let's do the same thing. Let's go 24 inch or 20, let's go halfway, 25 inches. Okay, we're going to be lifting up here, which may seem strange, right? But you're going to be lifting up here at half the distance. You're going to be lifting twice the weight. So now you're going to be lifting up here at 1,000 pounds. You put 500 pounds down at 50 inches. When you come out here at 25, you're going to be lifting with twice the amount of weight. So now let's keep going back here. Let's go to the back axle, all the way back to the back axle, which just so happens to be 50-inch wheelbase, 50-inch loader. So what does that mean? We're going to be lifting up right here on this rear axle at the full 500 pounds, which is leaving this rear axle to only have 250 pounds left on it. Well, if you had a two-wheel drive tractor, this would really spin really easily with only 250 pounds on it. This front axle now has all of that weight right here sitting on the front, right? So you have the 500 pounds you're pushing down on this side, the 500 pounds you're lifting up on this side, so that's 1,000 pounds. Now you're adding all this weight right here on this front axle. I don't know what the axle ratings are on this tractor, but it would be very easy to overload it, I feel. If you were, of course, it has to be rated for whatever the front end load or lift capacity is rated for, is obviously what the axle has to be rated for, or more, right? Because you have the weight of the tractor and everything. But at 50 inches, it would be much easier to overload this front axle than it would be this back axle at 25 inches. Not to mention, right, so which axle do you steer with? Which axle do you control the tractor with? Is the front axle, right? So if I can stick 500 pounds way out here at 50 inches, that's going to make this back really light, really teetery, right? So we're going to be able to steer really well, but we're going to spin out and we won't go anywhere. Or the rear end may slide around, right? So we're multiplying the amount of weight by sticking it way out front. If you have it real short right here in this front in this rear 3-point arms, the same amount of weight is only going to do half of the damage. Well, not damage, but it's only going to take half the amount of weight off of the front axle, right? So you're still going to have a fair amount of weight on the front axle to steer you, to guide you. You're going to get that good traction that you need. Plus, you can put a little bit of ballast on the front. You can put ballast on the back too, don't get me wrong. But you can still utilize your front end loader for, you know, if you're hauling this log back, you can have your saw in the bucket, or your axe, or whatever you're using. Your tools can be used in the front bucket. The rear can be used for towing that log around. So I hope that clears up why I like. All right, guys, sorry about that, but battery died on the camera again. I have the worst luck with these cameras and keeping the batteries up to charge. But you got the gist of what was going on there with the levers on the Geek Peak for today on our project. That's one of the reasons why I really like the 3-point attachment that we built today. Many different uses. You can put clevises on there. You can put the bolt-on hitch receivers, tow your trailers around. You can put weight brackets on, whatever you want. Real simple. You know, it was just a drawbar, generic, bought from Tractor Supply or Rural King or wherever. Didn't take a lot of time or material. It took about, I don't know, probably 4 feet total, you know, because we had less than 2 feet on each side of material. About 10 minutes really to build it. I hope this helped you guys out. Little information there about why, as far as stability wise goes, I chose the 3-point. Don't forget to follow along by subscribing. If you want to see more information like this, we're gonna keep going with this kind of projects. You know, we can give you guys the how-to and the technical details about it. So like and subscribe, follow along with us. We'll catch you on the next one.